Hi all, welcome to my YouTube channel Know About Embedded System. So in today's video, we will discuss about a dynamic memory allocation in C programming, and this is also one of the interview favorite topic. In most of the interview, definitely you will get a questions related to dynamic memory allocation. So before starting the video, if you're a new viewer to my channel, kindly subscribe my YouTube channel and gain the knowledge on embedded systems. So what do you mean by dynamic memory allocation? Dynamic memory allocation in C programming. What do you mean by that? So definition says like this: dynamic memory allocation is nothing but allocating the memory during the runtime of your program. Is called as dynamic memory allocation. And what are the advantage of this dynamic memory allocation? So important things are like this: you can allocate memory, you can use them, and you can resize them, and whenever your programming is done, you can free them memory. So this is a big advantage of dynamic memory allocation. You can allocate, you can modify it, or you can resize it, and you can free it once the usage is completed. Okay. And what do you mean by dynamic memory allocation? Allocating the memory during the runtime is called as dynamic memory allocation. So what is the difference in dynamic and static memory allocation? Usually in the static memory allocation, it's going to allocate memory in the stack, in the regular static memory allocation. But in case of dynamic memory allocation, the memory will be allocated in the heap area of your RAM. So this is the major difference between static memory allocation and dynamic memory allocation. So what are the advantages? As I told you already, we can allocate memory, we can resize it. Resize in the sense you can modify according to your requirement, and once the usage is done, once the memory is utilized properly, you can free it up. You can free the memory. So these are all the big advantages of your dynamic memory allocation. So there are 4 functions are available in our C programming in order to deal with the dynamic memory allocation. They are like this: one is a malloc, calloc, realloc, and free. There are 4 important functions in our C programming dynamic memory allocation: malloc, calloc, realloc, and free. So let us understand one by one how they are. So the first one is malloc. So what is a malloc? So malloc stands for memory allocation. Very straightforward definition. So malloc is a function which is available in our C programming, which is used to allocate the memory. Contiguous memory allocation. Malloc stands for memory allocation. What is the advantage? This function is used to allocate the single block of memory or single block of contiguous or continuous memory in the heap area during the runtime. So what this function, once the memory is allocated, this is going to initialize all your memory with a garbage value. So what is one small drawback is there with a malloc? So what is that? This is going to allocate the garbage value, uninitialized memory. So malloc will allocate the memory, but these memories will be allocated, or these memories will be assigned with a garbage value. So this is one small drawback you can understand. So this is also called as uninitialized memory. Malloc will allocate the memory, but it is uninitialized memory. So in order to use a malloc, we have a built-in function, as I already told. So we have a malloc function, and in this way we have to use this malloc function. So we have to use a malloc function followed by one parameter we have to pass. That is nothing but number of bytes need to be allocated. The parameter what you are seeing in the parenthesis, this part. Yeah. So we are going to use a function called as a malloc here. So this function will have one parameter, that's nothing but number of bytes need to be allocated here. So this parameter what you're saying, this we have to mention. So then we have to do the typecasting for integer. Then we have to assign to the pointer to which you want to point, memory where you need to point. So this is called as a malloc function, and this is how we'll be using. So let us consider here one example. So let us consider n is equal to 5, and consider size of integer. Size of integer is nothing but 4 here. 4 into 5, nothing but 20. So 20 bytes will be allocated like this. So in the memory, with this function or with this parameter, n is equal to 5 into 420, so 20 bytes will be allocated in the memory allocation with the help of malloc function. So I hope malloc you are clear now. So now we are going to discuss second function called as the calloc. So calloc, it is nothing but that stands for contiguous memory allocation. Contiguous allocation of memory is called as calloc. Okay, but one major difference between malloc and calloc, so the calloc will initialize all the memory with 0. Calloc will initialize all the memory locations with 0, but malloc will be uninitialized memory locations. Calloc will initialize memory with 0. This is only one major difference between malloc and calloc. Yeah, so it is used when we need to initialize memory with default value as 0. So this is the difference as I told. So in calloc we have two parameters. One is amount of memory we have to specify, and second parameter is size. So two parameter we have to mention for calloc. It is exactly similar to malloc, but one small difference. So one major difference is calloc will initialize memory with 0. Second major difference is we have to pass two parameters here. So first parameter will be size of your variable. Example here, size of integer, nothing but that's the first parameter. Second parameter is amount, in the sense how many bytes we have to allocate. So 5, example I'm giving here 5 on size of integer. For now what it is going to do, yeah, calloc, so in this way it is going to allocate here. So contiguous memory allocation, 5 into size of 4. That means it is going to allocate 4 bytes of memory of 4 bytes of chunk with the 5 numbers like this, and initializing with 0, 0, 0. So this is how the calloc function will work. I hope this is clear. So we have realloc. Realloc, it's a straightforward definition. It is going to reallocate the previously allocated memory block. Realloc stands for reallocation of memory, which is already defined. So it is going to allow user to reallocate the memory without changing major changes. Okay. Suppose now you can see here, I have one example here. I have allocated some 20 bytes of memory here. So in the first line, but in future, if I want to change it, so I have to use like this. So I'll be using a realloc function, realloc. So pointer which I'm going to use, that one I need to mention here. The pointer followed by how much size I want, and followed by size of integer. It is exactly similar to malloc function only. Okay, so I hope so the realloc is also clear. Realloc is used to reallocate the memory size. Okay, so this is how we'll be using realloc, pointer name, and size, modified size, and size of integer. Okay, so this is our realloc function. And finally, we have one more function called as free. Very straightforward definition here. We have to free the memory once it is utilized in your program. So once you have used the memory, and after utilizing your memory from the malloc and calloc, so we have to free it. So that can be done by the function called as free, in order to avoid our memory leakage or memory fragmentation problems and all. So I hope this much is a theory part. Now I'll take you directly to the coding, and in the coding we will understand how can we use malloc function. So now I have one function. I need to allocate a memory here for n is equal to 5. So for that, I'll be using one pointer here, start ptr is equal to, I have to use a malloc function, malloc followed by, so I need to specify how many bytes, and then size of integer. So this is how I'll be using, and before that I need to use typecast it. So integer star. So this is how I'll be using a malloc function, malloc. size of integer, and n is equal to 5 here, and I'm going to assign to the one of the pointer here. If I need to check here, if my pointer is pointing to null, then you can say that the memory is not allocated, and you can return something called as a 1 here. So here I'm using assign memory, allocate memory. So this is called, I'm going to allocate memory. Okay, so here check memory allocated or not. My pointer is pointing to null. You can say that memory is not allocated. So this is the second condition. Now I'm going to use the memory. I'm going to use the allocated memory here. So if you want to use the memory, I'm just using one for loop here, and integer I is equal to 0, I is less than 5, and then I plus plus. I'm just storing some small data here. Use the memory. So pointer of the first memory location I'm going to use with the help of pointer is equal to, so I star 0. I'm going to print the data here. I'm going to pointer of I I'm doing here, and after using this pointer we have to free it up. So how can we free it up? So we have to use a function called as free. Just free followed by ptr. So this function will free the memory which I have used, and finally you can just mention ptr is equal to null. So this is called freeing, and this is I'm going to assign as null. So now let us run this code, and so now you can see, so it is allocated memory and it is able to print the numbers. So what is the meaning here? The first thing is memory is allocated. Okay, and after memory allocation, I'm using for loop here to enter the data to the memory. I'm just entering 10, 20, 30, 40 like that. So 0, 10, 20, 30, 40, and then I'm just printing them, and then I'm just freeing up. Right. So in this way, we can use dynamic memory allocation functions such as a malloc, calloc, and realloc. The similar way to malloc, we can use calloc and realloc as well. So I hope this video is clear to all. So if you feel this video is clear, please click on like button and subscribe my YouTube channel.